Hi, back with me. In this video, I will try to create a Minesweeper game in Flutter. I already have my finished game in the right. Uh, it is a normal Minesweeper game where you can set a flag, delete a flag, and just guess where the mines are. In this example, I set the mines or the bomb is 2, so we can easily win the game. And you can reset the game if you already finished or you have game over. Yeah, this is the game we will try to create. Okay, now let's back to our app. In this app, as my previous template, I already set my theme right here for light and dark theme, but I only use light theme. And for the router, right now I'm using Go Road. You can check it out for the detail, or maybe I will create another video for this. But right now I use Go Road with the initial location is home because I only had one page, which is home page. Okay, now let's jump into code. First of all, let's create the flag and the reset button. The flag and reset button, use padding, symmetric, horizontal, and vertical 16. Side padding, I will have a row. This I will use this one. This I will just set the dummy data flag. Okay, let's create the button. Button will be elevated button with a icon. It has icon reset and label text reset. I will be styling this so it has a primary color and shape with a rounded radius, like this one. Okay, now let's create a let's create our grid. But first, we need to uh, add a custom class for storing our cell data. It has a row, which is final, and column, and other properties like hasMine, is open, is flag, or adjacent mines, or sum of surrounded mines. Okay, now let's create our cell. In our cell, we will have convert this to a stateful widget and make this property. We have 12 row, 8 column, 2 mines, and list of grid, which we will create it later in init step. Okay, now let's create the initialize grid. Okay, now let's create the function initialize grid. Initialize grid. Okay. Inside of initialize grid, we will just add the grid in here. The grid is has 12 rows and 8 rows. So we add cell based on this generated list. Okay, after that, we'll create the grid first, below the padding, okay. Below the padding, we will try to create a grid using grid view builder. We'll know that first. First one is we will set the padding to 24 and p6 for never scrollable scroll p6 because we already have a list view with scrollable as a parent. So we need to pass this p6 and string warp to true. And the item count is rows times column. So we item count rows times column. So we have all the cell we need. And the grid delegate, we using sliver grid with fixed cross-axis count with columns, and the main spacing is 4, and the cross-axis is also 4. Okay, for that, let's create the item. Context and index. First one is we will try to find which is row which is call using this calculation. Row and call by this function index, and let's create our cell. Return a gesture detector first and a container. I will just copy paste from the Finish app and I will explain to you guys. Okay, first one is we will have our cell in here, and the decoration of this will be like that. We will have a border radius of 8. The color is based on the cell state. If it is open, then it will be white. If the cell is flag, it will be primary swatch with 100. And if it is not open and not flag, it will be a primary color. And it also will have a box shadow. These two, okay? And the items and the children of this container will be the text of the adjusted mines or the flag based on the cell state. If it is open and it has mines, it will be a bomb. If it has no mines, then it will show how many mines are surrounded the cell or the adjacent mines. If the cell is flag, it will show the flag, and if it's not, then it will show nothing. Okay, let's save this and hope, yeah, we already have our cells. Let's set this default is open default to true so we can see the number and the bomb. Let's refresh. Now this one has no bombs because we are not adding bombs in our grid. Now let's do that. Okay. Sorry. For adding a mines or a bomb, we will use a random class from Dart. We will use this random class from Dart math, and we will look for the total mines. The total is 2, so it will look twice and add the mines into the cell. We has a random row and random column, and check if that row, if that cell has a mine, then we will not add another mines. But if it not has a mine, we will add mines to that cell. So we will have our mines ready by using this random cell. Okay, let's hot reload the app, and we will see that we already have mines randomized each time we open the app. But how we calculate, for example, this cell has one neighbor mines or adjacent mines. So how can we indicate that this cell has mines surrounded? To do that, we can use this calculation. Okay, to do this calculation, and we need a directions. The directions is a list of offset. I put it right here. Now, the directions is a list of offset, so we can check the surrounded cells. For example, we check the cells, then the directions will be here, 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 here. Basically, it will check the surrounded cells. Okay, so now for calculating adjusted mile for each cells, a number 0 or 8 based on the surrounded neighbor mines. We will look through the cell So we check each cell, and if it has mines, then we will continue because we don't need to check the adjusted mines if it already has mines. For check the adjusted mines, we will look through the directions and check. Oh yeah, I haven't added the validation for valid cells because it can be not valid because, for example, if I check this cell, the first one, it will check the surrounded uh, it will check the surrounded, but it will not valid cell because the cell is not there. If I check this one, then it will check the left one, which is not there, so it's not valid. So I need to check first if it is valid cell or not. So yeah, okay, we will look the surrounded mines in all directions, and if it is valid cell and it has mines, it will uh, increment the adjusted mines in that cell. Okay, and we set the adjusted mines in all the directions to the cell, so we can show it on the cell right here. So if I refresh this app, the adjusted mines is successfully adjusted. For example, like right here, this cell has only one mines, so it show the number one. This one has two mines above and bottom, so it show two in the cell. If I refresh this, it will also calculate based on how many mines are surrounded the cell. If I, for example, change the total mines to 10, it will also have 10 mines or bomb, and the number will adjust based on how many mines are surrounded the cell. Okay, now let's close this. Let's close this and add gameplay. Okay, the gameplay is on the gesture detector. We set on tap, and the on tap is we will be handling cell tap, which require a cell. Okay, we'll add in here void cell. Okay. For the handle cell tap, we will check first. It is game over, is open, or is flag. And we need to add two more properties in here, which is indicate the flag count and the game over state. On handle tab, we will check if it is game over or the cell is open or the cell is flagged. We will return immediate because we don't want to do anything to the cell if the condition is matched. Okay, now let's check. Let's open the cell. First, we will open the cell, and if the cell has mines, we will set the game over to true and open all the cells for revealing the answer. Else, we will check for the win. We will create the function check for win. Check for win is a simple function where we check for each grid, check if we still has an open cell that are not mines. If we has no mines, then we immediate return, indicate that the game still not over. But uh, if we already open all cell and it has no mines, the open cell is not a mines, then we will return true because we already win the game. Okay, so basically we iterate through all cells to check if there is if all cell is open or not. Okay, if we win, check for the win return true, then we will show game over to true to indicate the game is over, but we will show different dialog letter. Okay, and we open all the game, all the cells. Yeah, and the last one is we check if the cell is has no mine surrounded, then we will open other adjusted cell that are surrounded the cell. Okay, I will try to explain it later on the game, but let's create the function first. Open adjusted cell. Right here. We will open the agent. If adjusted mines is 0, we will open all cell if there is no mines nearby. Okay. We call this function. This function is we open the neighbor. Basically, if the cell is has no mines, then it will open all its neighbor to search the mines nearby. Okay, it will iterate or looping to all directions, same as yeah these directions, all the directions. It will check if it is not mines, not open, and is valid cell, and it will open the cell. Okay, it will open the cell and check if it is has no mines in its surrounding. Open adjusted cell in that positions. This process will get loop until it find the mines. If the neighbor cell is also has no mines surrounding it, then it will open another cell. So it will be recursive until it find a mines, until it find a cell that has mines surrounded it. After we look for that, there is a case when, for example, it will be like that. Okay. Where are we? Okay. Yeah. After we look through the direction, we will check if it is already game over or not. And if it is already game over, we will return. And if when we open the adjusted mines and win, we will check that. So if we not check this one, for example, let's set this to 1, so it will has only 1 mines, and I opened it, it will not indicate that the game is finished. To indicate that, I will add snack bar first, so we will see if we are successfully guess all the cell or game over. We will add the snack bar to this one. And we will add the snack bar to this one. If it is win, then we will show congratulations, and if it is game over, we will say game over. Okay, let's refresh this one. Yeah, it will not immediate say that we are winning the game because we don't check this. But if we check for win in open adjusted cell, it will say, okay, let's see. Okay, not that one, guys, not that one, not that one. Nah, this one, it will show that we are already win when we are open adjusted cells. Okay, now let's create two more function, which is this flag and this reset button. First, we will create a reset button in here. Maybe yeah, the reset button, we will just set the grid to 0, the grid to empty, the game over to false, and flag count to 10. And we reinitialize our grid. Okay, now let's just add this function to the reset button. Now when we reset, it will reset the game and change the mines positions. Now the last one is we will set the flag. Okay, for the flag, we will use in this gesture detector on long press. On long press, we will use handle cell long press. And cell. And this one is will be like this. Check if the cell is open, then we will return because we don't want to set a flag in an open cell. And we check the flag count. Flag count. It is always 0 because I'm not put the variable in this, so I will put this first. Flag count dot to string. Okay, now let's continue to the explanations. First, we will check if the cell is open, and if it is open, we will immediate return because we don't want to put a flag in the open cell. And we check if the cell is if the flag count or the total flag is already 0, or we don't have any more flag, then we will also immediate return. If it is not these two conditions, then we will set the cell is flagged to its reverse. For example, if it is flagged, then it will not flag, then, and if it is not flagged, then it will set to flag. I'm sorry if my explanation is a bit confused. Basically, it will use like this: cell that is flagged, check cell that is flagged false, true, then it will be false, and other it will be true. This one is same as this one. Okay, I will use this one because it's shorter. And if the cell is flagged, we will decrease the flag count, and if the cell is remove the flag, then we will add the flag count. For example, if we flag this, then the flag will be decreased, and if we remove the flag, it will add the flag. And if we already has the flag, we can click or open this cell because it already flagged. It has a flag on it. If we want, we need to remove the flag and open the cell. Then yeah, we can play the game. It is all the functionality Minesweeper has. Let's change this back to 10 and refresh. Okay, this will be a bomb, then game over because I opened a cell that is boom. We can reset that. We can play. And for the adjusted mines, this open adjustment cell will be look like this one. If we choose if we choose 0 or 0 adjusted mines, it will open all of its surrounding until it finds a cell that has mines surrounding it. So it will open all the cells until it finds a cells, which is this cell which is has two mines surrounding it, this one and this one, and it will stop right there. That is that what this function do. Maybe you need to understand the concept of Minesweeper game for understanding these functions, but basically this function is do this. We'll open all the cell until until the cell has mines surrounding it. So yeah, this is the final game. This is only take 300 lines to create a Minesweeper game in Flutter. It is pretty easy actually. You can add a system level maybe or a timer. We only need to play around with this row, column, total mines, and flag count. We can add, for example, 42 rows. It will be a lot of rows, yeah. And it will be a lot of rows and easier win. Yeah, you can play along with this. So that's it, guys, for this video. I hope you understand what I'm saying. So see you in the next video.